Hello everyone, myself Dr. Praveen Kumar, working as Associate Professor in the Department of Aeronautical Engineering, Institute of Aeronautical Engineering. Welcome to Aircraft Propulsion and Turbo Machinery course. Through this course, students will try to learn the fundamentals of air-breathing propulsion system and their individual components and functions and working principles of individual components like inlet, compressor, combustor, turbine and nozzles. And also they will try to learn the flow behavior through these different components of turbojet engine or gas turbine engine. And at the end of the course, students will be in a position to compare different types of all these components, like different types of inlets, different types of compressors, and different types of combustors, then similarly turbines and nozzles as well. And of course they will be in a position to analyze performances of these individual components based on their performance characteristics to select a suitable component as well as in overall to design a suitable engine as per the given requirements. Right. Once again, I welcome you to this course, Aircraft Propulsion and Turbo Machinery. And in this lecture, describe basic components of turbojet engine and working principle of turbojet engine. These are the basic components of a turbojet engine, that is inlet section, and up to this inlet section, then compressors, and then combustors, and then turbines here, and then exhaust, that is nozzles. Right, these are the major components of a turbojet engine, that is inlet, compressor, combustor or combustion chamber, turbine section, then exhaust section, which are nozzles. Right, we'll see one by one. So the primary function of the inlets are that to capture free stream air and transfer it to the immediate component of the engine, that is compressor. Right. So function of the inlet is to capture as much as huge amounts of free stream and transfer it to uniformly to the compressor with less losses. Right. And the position of the inlet is just before the compressor. Of course, there is an initial part of the among these all components. This is the first part, and especially inlets doesn't do any work on the flow, and proper inlet design and inlet performance has a strong influence on engine net thrust. That is like properly designed inlet should transfer free stream air with less losses, that is like less pressure losses and less velocity losses. Right. And at the same time, certain cases, like few inlets will most of the times inlets will also compress the air and prepares the air before entering into compressor. If it is inappropriately designed inlet, which might result in losses in the pressure, and also which might result in losses in the velocity as well, and which results in overall reducing the efficiency or performance of engine. Right. A good design inlet should of course will compress the air ahead of the compressor, and it will transfer to the compressor, right? And different types of inlets are subsonic inlet and that is supersonic inlets. Mostly subsonic inlets are like divergent section, and supersonic inlets are CD nozzle or convertible inlets will be there, like as per the airflow required, as per the power requirement, thrust requirement, geometry will change. Yeah, and this is how inlet looks like. Mostly this is a subsonic inlet, and subsonic inlets usually, otherwise subsonic flights depends on a smooth contour inlet, and also if the one more point, if the inlet is inappropriate, it also leads in increasing drag as well, right? Which really of course reduction in the pressure losses and velocity losses and increasing drag, all these things will disturb the flow in the compressor, then will result in sometimes compressor stall or surge, and otherwise will result in unstable combustion, which is combustion instabilities, which altogether results in vibration as well as which may lead to engine failure as well. So this is importance of the design as well as selection of right inlet. And the next component is in the turbojet engine compressor. The primary function of the compressor is to raise the pressure, that is to compress the air, whatever the compressor received from the inlet, raise the pressure, that is compress the air, and then send it to, in appropriate way, send it to the combustion chamber, where, that is preparing the air for better combustion or efficient combustion, so that engine might give more thrust or might give more power, right? So its primary function is to supply air in sufficient quantity. This is also another point, sufficient quantity and the required pressures, right? So the compressor must increase the pressure of the mass of the air received from the inlet. Yes, that's what we have seen, and discharge it to the burners. The compressor is composed of many rows of small aerofoil shaped plates, that is rotors and stators, and there are multiple stages of compressor, like low speed compressor, then high speed compressor, and each, of course, in each category there continuous row of for example, first rotor blades, then immediately followed by stator, then immediately followed by rotor. The arrangement will be like this. We'll see in the next slides. Different types of compressors are axial compressor and centrifugal compressors. Yeah, this is how the arrangement of compressor looks like. Initial stages, low speed compressor, then slowly high speed compressors. Even in each category, as discussed, like stator and rotor arrangement will be there. The rotor blades will rotate, whereas stator blades of the compressors will stay fixed. They won't rotate. Only rotors will rotate. So the functions will be like this. Rotor blades increases the pressure, and as well as it adds some energy, kinetic energy to the flow. Then immediately stator blades will do opposite, actually opposite in the sense will decelerate the flow but increases the pressure. So rotor blades, by as they are rotating, they will increase the pressure and accelerates it, and then send it to the immediate rotor stator blades, where stator blades will decelerate the flow but increase the pressure. This is continuously repeats until the end, and in the low pressure compressor region, it deals with that compressor deals with little low pressures, that is whatever the air received from the intake, little pressure will be increased in the low pressure compressor region, whereas high pressure compressor region, high pressure compressor will increase the pressure little more, or as per the design, as high as required to the combustion process. Yeah, these are the few components of compressor. Like this is how rotating blades looks like. The arrangement will be look like this, and blade size will vary from longer to the shorter one. Usually longer blades will be in the beginning, which deals with low pressures, and slowly the blade size will decrease, and this is how the pressure distribution, immediately after the intake, the blades cannot sustain initial stages of blades cannot sustain high pressure, so slowly the increase in pressure will take place in this way. So larger long blades or larger blades will be in the initial stages, and then slowly the size will decrease and pressure will increase, right? And the arrangement will be like this: rotor and stator. As we have seen, rotors will increase the pressure and add kinetic energy to the flow, and then stators will decelerate it and increase further the pressure will be increasing here, and this repeats until the required pressure rise is achieved. The high pressure air and high velocity air is supposed to immediately send to the combustors, but actually in between diffuser will be there. That is because the purpose of the diffuser is if the high pressure and high velocity air is pumped into combustor, where fuel will be added to it and combustion takes place. If this is a process, actually due to this high velocities, high pressure as well as high velocities, improper flame or improper combustion would be expected actually. Otherwise it results in improper or inappropriate combustion, which leads in inefficiency of the engine. That is the reason a diffuser will be there in between high pressure compressor and combustor, where it decelerates the airstream, increases the pressure, decelerates the airstream, and that decelerated and increased pressure air will enter the combustor, and through the injectors in the combustor, fuel will be added. So overall the purpose of the compressor is to raise the pressure, so that more fuel and fuel burn will be more efficiently. Actually, combustion of fuel will take place more efficiently. That is the purpose of the compressor, right? But in between, the diffuser will be there. That is to make sure that proper combustion takes place, proper mixture and burning of the fuel and this air combination will take place. That's the reason, because with high velocity, high pressure air, if it enters the combustion chamber, then unstable combustion, it results in unstable combustion. So for that purpose, diffuser will be there actually. And then the role of the combustor is to otherwise combustor houses the combustion process, where temperature will rise. Otherwise, that combustion process will result in increase in temperature of the mixture, and whatever is passing through the combustor. And the primary function of the combustion section is to burn the fuel air mixture, thereby adding heat energy to the air, and of course this releases the energy, and next this exhaust of the combustor will be transferred to the next component, that is turbine, right? And different types of combustors are can type and cannular type, and both the things actually combustors are like cans arranged circularly, otherwise circumferentially. And second, the other difference is, in the can type, combustion will take place in each can separately. Otherwise, in each combustor separately. Each one will have flame holder, otherwise injector, and combustion will take place separately. Whereas cannular type, cans are there, but there is a common annular type provision will be there where combustion takes place. So common combustion exhaust will be there. And the next components are turbines. The main purpose of turbine is to extract the energy from this high temperature exhaust from the combustor, right? The reason for existence of turbine is actually in the design gas turbine engine or turbojet engine. That is to get the energy, to extract the energy, to get the energy to drive the compressor. That's a major purpose of the existence of the turbines. So these turbines will extract energy from the exhaust of the combustor, that is combustion exhaust, right? So the high energy airflow coming out of the combustor goes into the turbine, causing turbine blades to rotate, and the turbine transforms kinetic energy of this exhaust into mechanical energy, that is to drive the compressor, right? Here also we can expect, here also as there are low speed compressor and high speed compressor, otherwise low pressure compressor and high pressure compressor. Turbines also high pressure turbine first, then low pressure turbines will be there. So immediately after the combustion, high pressure turbines are placed. So this which deals with the immediately exhaust gases from the combustor, and which extract most of the energy from the exhaust, and which is used, kinetic energy converted to the mechanical energy through the shaft, which is used, that energy is used to drive high pressure compressor, right? And the remaining part of the energy will be extracted by low pressure turbines, and that energy, again here also same principle, converting kinetic energy into mechanical energy, and that is to drive low pressure compressor, which are connected through shaft, right? So this is the purpose of the turbines, and there are here also two stages of turbines will be there, high pressure and low pressure. And of course, in both the cases, high pressure compressor and high pressure turbines, obviously materials should be different, and they should be in a position to hold, if it is compressor blade, high mechanical stresses, and if it is high pressure turbine, along with high mechanical and of course a high thermal properties also should be there, and because they are the one which are immediately exposed to the combustion exhaust, right? And then next one is low pressure turbine, where little lesser thermal stability is required when you are comparing with high pressure turbines, right? So this is one region where this is one part component in the turbojet engine which requires actually advanced materials. Okay, another part is a combustor, where the temperatures will be very high, and then immediately after that is turbine blades, especially not only temperature but mechanical. These blades are subjected to mechanical stresses as well. So advanced materials are expected here. Which are required here. Of course, they are made of advanced materials. Whereas high pressure compressor blade, there we need not to consider much about high thermal. Materials with good thermal, high melting point, and so on, thermal properties, right? So turbines are also two types: axial flow turbines and radial flow turbines. Yeah, the next component is next and last one is nozzles. And so far we have seen actually inlets will supply the free stream air in a proper way with less losses to the compressor, and compressor either high speed, low speed, and then high speed compressor together, and with these two stages, and with rotor and stator blades. It raises the temperature, raises the pressure of the air. Then after that, immediately after, through diffuser, those high pressure, highly pressurized gases at high density will enter the combustor, where fuel will be mixed, combustion process will take place. And see, in the combustor also, actually 1/4 of the air will be used for combustion process, and the remaining air will be such a way that it shields the combustor, where such a way that high temperatures will not really touch the combustor walls. Then turbines will extract the energy from this exhaust, high temperature exhaust and high velocity gases, and will continue to drive the compressor part. Then whatever the energy left, now this energy will be thermal energy as well as pressure, everything will be converted to kinetic energy through nozzle. Kinetic energy. Nozzle is a component where it actually, in a way, generates the thrust, required thrust. Okay, this accelerates the nozzle accelerates the flow. Otherwise, it converts this thermal exhaust energy, heat energy, into kinetic energy. That's how it generates the thrust. That is, as per Newton's third law, action, for every action there is a reaction. That reaction is thrust, which makes the vehicle move forward, right? And here also, this is the major function, converts the pressure energy available from turbines to kinetic energy, and it provides the thrust. And see, thrust vectoring also possible to achieve maneuvers, climb rate, which are not possible by conventional way. Actually, so kind of movable components will be there in the nozzle. Which helps in changing the maneuvers as whenever required. And thrust reversal also possible. You can get thrust reversal also. Nozzles are deflected so as to generate reverse thrust, and nozzles come in a variety of shapes and sizes depending on the mission of the aircraft, and of course based on thrust required, nozzle shape also you can change or modify actually as per the altitude, right? Such nozzles also are available. So in this lecture we have seen, once again I'll go back to first slide. In this lecture we have seen what is a primary function of the intake, otherwise inlet, primary function of the inlet, and then types and function of the compressors, that is what is subcomponents of compressor as well, that is low pressure region, high pressure, stator, rotor, and there are a few issues as well, that is like in any way through the inlet or in between, also through the rate flow through stator, rotor, also there is a possibility of stall, similar to aerofoil stall or wing stall, right? Where flow separates from the blade, right? Which results in increasing the drag as well as flow separation, which results in compressor inefficiency, and then of course which results in which affects the combustion process as well. And compressor surge also is there, where huge losses, sudden change in flow, which results in huge noise, vibration, right? So these are the issues to be dealt actually through different methods, providing the separate valves or other mechanisms, right? Then here we have seen diffuser also will be placed there, and then through which velocities or speed will be reduced or decelerates the flow but increases the pressure as per Bernoulli's principle. And in the combustor, fuel will be injected, then combustion process will take place. This is what I said, like some part of the little part of the air sent only will be used for combustion process, remaining will be like this shielding, so that actual temperature will not hit the combustor walls. Then it will be processed through the turbine, and high pressure turbines and low pressure turbines. high pressure turbines will whatever the energy extracted from the combustor, high pressure turbine will drive the high pressure compressor. Then low pressure turbine will drive the low pressure compressors. Then nozzle, we have seen function of nozzle, which converts the heat energy into kinetic energy, and overall nozzle will accelerate. Nozzle is the one which generates the thrust. Nozzle will accelerate the flow. That's how we'll get the thrust. This is what we have seen in this lecture, and these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.